Ladies and gentlemen, the summer course is going to start. Please be seated. All participants are expected to change the name according to the format group underscore name underscore country and kindly use the virtual background during the lectures. By informing the attendance of the participant is an important factor in determining the success of the summer course. Therefore, it is important for participants to attend the entire agenda. All participant microphones are muted during the lectures. If you are having any question, please inform us in the chat box and kindly unmute when the MC or moderator give you permissions. Thank you. Honorable, distinguished lecturers and participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Peace be upon us. Good morning and our very warm welcome to all of the speakers and participants for gathering back on the third day of Summer Course 2022 with the theme of Sustainable Infrastructure and Built Environment. My name is Nur Afian Desyani, accompanied by Nur Wahid Dimasa Putro, will be the master of ceremony for today's course. Honorable, distinguished lecturers and participants, ladies and gentlemen, today's summer course agenda is as follows. We will have course 5 presented by Dr. Satyanto Krido Saptomo from Indonesia. Then we will have course 6 presented by Dr. Prastowo from Indonesia. Then we will have a quiz group discussion. This course is gathering students, researchers, and practitioners who are responsible for delivering sustainable and eco-friendly solutions through leveraging advanced civil and environmental engineering. This course also provides a great opportunity for prospective participants to share their recent theoretical knowledge and experiences in dealing with sustainable civil and environmental engineering that are also featured by presentation from international speakers. So, honorable, distinguished lecturers and participants, ladies and gentlemen, now let's start this session with course 5 with the topic Smart Water Management. This course will be delivered by Dr. Satyanto Krido Saptomo. Dr. Satyanto received his doctoral degree from Department of Bioresources and Bioenvironment Sciences from Kyushu University, Japan in 2004, and his master degree from Agricultural Engineering Sciences in IPB University, Indonesia in 1999, and his bachelor degree from Agricultural Engineering, IPB University, Indonesia in 1996. He has been actively doing research, and some of his research are about agricultural water management, smart water management, smart irrigation and hydrology, subsurface irrigation and drainage, rainwater harvesting, and instrumentation, monitoring, and automation. So, to Dr. Satyanto, good morning. Are you there?
Yes, I am here. Can everyone hear my voice?
Yes, I can hear. So, to Dr. Satyanto, time is yours.
Okay, good morning everybody. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Let me start my lecture in this morning. Okay. The committee has actually the committee asked me first to give a lecture in water footprint. However, I asked to change the topic since maybe I can how to say it, I can talk more in this topic rather than the water footprint. Although we will get into the water footprint at the end of my lecture today. Okay. Can everyone see my screen?
Yes, we can.
Okay. So I'd like to give a lecture, talk about the smart water management. I think today's the smart system has been a trend, as we are getting into the industrial revolution 4.0. So everybody is talking about a smart system, like smart housing, smart anything, many things. Yeah. So in this case, also in water management, also, we introduced. It had been introduced. We had been introducing a smart system in managing water for many purposes. So this is me. Before we goes on, if anyone want to know me more, you can try this social media and also the Sinta website. I think you already be able to download these slides, so you can just click the link and from the material already uploaded in OpenCourseWare website. Now, today I'd like to talk about a few things. First, of course, the smart water management in general, and then we get into detail a little bit to smart agricultural water management, since we are in IPB University, which is basically agricultural university at first time. And then I'd like to introduce a little bit about our current research, and we will go a little bit to water footprints, and we close with remarks. Smart water management in general. Let's start with this news. I took it from this website. If you can open the slides, then you can just click this link, so you can get the this news. Let's read this. The Ministry of Public Works and Housing said that in the future, the management of water resources in Indonesia will implement smart water management, or abbreviated as SWM. For this reason, the ministry encouraged to take advantage of advances in information technology, such as the development of integrated water resources management, IWRM, and the application of information and communication technology, or ICT, which will result in higher quality management of water resources, known as smart water management of water resources, or smart water management. So in this news, we can get some keywords regarding the smart water management that is adopted by Ministry of Public Works and Public Housing. In this case, maybe we can see at first there is keywords IWRM, Integrated Water Resource Management, and the application of ICT, and also the terminology of smart water management itself. Let's continue. The second is also from the Ministry of Public Works. This is especially in the management of the Cisangkuy subwatershed. You can also visit the link. However, these are in Indonesian. Okay, so I translated. Well, it's actually machine translated, so maybe the grammar is not too good. However, I hope it's still can be enough properly understandable. So the Cisangkuy subwatershed as reservoirs. You can see this is the scheme of the subwatershed and the water management. The Cisangkuy subwatershed as reservoirs used for hydropower plants, clean water intakes, and irrigation areas. So there are three purposes of this subwatershed reservoirs. The large number of infrastructures and other water structures in the subwatershed requires effective and efficient integrated water resource management. Again, IWRM keyword is out. and we learn effective and efficient in the management, so that all can function, all that can function according to their respective functions. So it all so that all can function to their respective functions. So simply saying, they should function as they are expected. And therefore, the application of the smart water management system is carried out to optimize the integrated water resources management so that the potential of water resources can be maximized. To optimize the management so the potential can be maximized. So here we can get some other keywords that the system is aimed to increase the potential or increase so that the potential can be utilized at its maximum, like that. We continue. The application of a smart water management system combines the function of sense and control to describe and analyze the optimal water balance in the Cisangkui watershed and provide water resource management decision based on the availability data in predictive or adaptive methods so that they can take smart actions. So here we need data, we need information, we need something that we can analyze to take smart action, to make decision of a smart action. Smart action is, I mean that the smart action should based on information, accurate information based on data, something like that. So in this case, the smart water management usually use devices, instrumentation like sensors or something like that. We will talk later. The smart concept here is the development and operation of an integrated, effective, and efficient water management system model supported by a timely or real-time data preparation system so that the water supply and operation of the existing infrastructure system in Cisangkui subwatershed can be carried out optimally. And again, we have the importance of smart water management system is to upgrade the operation, the management, so that it can be carried out optimally. Can we continue? This is from Indonesia. Let's go to other website from outside Indonesia. This is from this website. What are smart water management system and how do they work? How do they work? Smart water management is the activity of planning, developing, distributing, and managing the use of water resources using an array of IoT. Does anyone familiar with IoT terminology? I think it's very famous terminology these days. Is the Internet of Things. So everything's connected to internet, including the sensors, including vehicles, including other control devices, something like that, including maybe you have watched or even now I think a CCTV or what is in English, stop contact, the electric plugs. Yeah, it's also there are many devices already being sold as IoT. So in smart water management system also, they use IoT technologies which are designed to increase transparency and make more reasonable and sustainable usage of these water resources. So again, we need this basically the needs of real-time information. It applies to multiple sectors: agriculture, farming, industry, services, cities, and monitoring water consumption in houses, checking water levels, checking the quality of drinking water, detecting chemical leakage in rivers around plants, tracking pressure variation along pipes, or checking water quality in aquariums, and many other application of the smart water management. So when we are talking about smart water management system, it's not actually limited to such one purpose, but also depends on what is our field of expertise maybe, or what is our requirement, what is our needs to be managed with smart systems, something like that. It continues. This is from the same website. So usually we will get into the usage of microcontrollers and sensors. I think these two terminologies also not so strange nowadays. Many of us already bring microcontrollers every day, our gadget, our many things. Yeah. Also sensors in your computer, in your smart watch, you already have sensors. But in the smart water management system, the sensors is mostly related to water, indirectly or indirectly. For example, ultrasonic sensors, flow sensors. Ultrasonic sensors can be useful to monitor water level, something like that, or distance. Okay, temperatures, salinity, conductivity, humidity, pressures, or luminosity sensors placed on pipes or pumps measure the water levels, flow, temperature, quality of the water in real time. So again, this is the most important thing is the information or data in real time. Message alerts and data generated by the sensors are transmitted over the internet to a cloud servers. So when we are talking about smart water management system nowadays, it almost always should be related to internet and cloud servers. So after the data goes into the servers, went into the servers, where the data will be processed, analyzed, and maybe further processed by artificial intelligence and sent to terminal for the user to consult. I mean, the result of analysis will be used for decision making, what to do with our water infrastructure. And the system can then control and regulate the usage of quality of water resources, as well as facilitate the maintenance of default equipment. So we can design the system actually to work autonomously. I mean, automatic, without interfere of human operators. But we can also limit the system to give warnings, alerts, and information of what we have to do with the infrastructure, something like that. Okay, we continue. I think these are some benefits of smart water management system. First, because water, so it is related to water intensive industries. I think you know the most water intensive industries is, yeah, I can say agriculture or farming. Yeah. So at first we can reduce the waste of water intensive industries, means water losses or extremely polluted water, something like that, because we can monitor all the condition at real time, and then we can anticipate at real time also, immediately anticipate. The second is the monitoring water quality to fight pollution and disease. Third is improving the efficiency of water system. So maybe later I will show you some examples for how we can manage irrigation water just as it needed. So sometimes with the conventional irrigation system, we cannot avoid the loss of water through overflow or to percolation, something like that. So if we can use the smart water management system in agriculture, we can improve the efficiency of water system. Also in other purposes. And then because mostly in a smart water management system, measurement is a must. We have to put meters, sensors to quantify how much water is used, what is the quality of the water, then the awareness of household water use also can be created or increased because we have the meter, smart meters, water flow meters that we can see anytime. We know how much water we use and then how much money we have to pay. So the household, I think, will have increase in awareness of the usage of water. And the fifth is providing running water through innovative solution all around the world. I mean, yes, because the smart water management system does not limit the technology as what is now available in the market, but also look it is important to look over the available technology. So I think these are 5 benefits of smart water management system that I took from the previous website. We go to I think this is the fifth website, the fourth website. This is an example of smart water management system in smart application in water sectors. But this here is more in municipal or domestic water supply, I think. Let's say maybe it is not easy to explain what is this in this part, but you can see later. Let's focus on what is written at this section. A smart water management system includes the water treatment plant and water supply network. And so in this case, the smart water management system is applied for water treatment plant and also water supply network. It involves the data collection, information processing, analysis, and presentation. So I think these are what we expected when we are planning the smart water management system to be applied in any purposes of water management. In this case, is for clean water supply. However, in any other case also, we need data collection, information processing, analysis, and presentation. Presentation can be in the form of application where you can see the parameters, what is the discharge now, what is the water level, what is the quality of water, something like that, or using the website. So in this case, they said that smart water management aim to secure the water resources, supply safe, provide safe water supply and resilient water supply, improve revenue water ratio. I think this is for the company, and to sustain water supply and to reduce operating cost. So this is I think the additional benefit, how to say, especially for this case, the smart water management system in domestic clean water supply. And so these are the technology that usually used in smart water management. First, of course, maybe the most level that being used in smart water management nowadays is the first and the second. The first is basically the instrument that can measure and can supply digital information. So we need digital acquisition, a data acquisition system in its sensors. The purpose is to collect and transmit information in real time. Again, information in real time is very important. What is the example of this instrument or this component? If we talking about water, then we always need to know the source of water, which is mainly actually rain. So we usually use rain gauge, flow meters, water quality monitoring, and other environmental data, and sensor, of course. And also, if we are talking in water distribution, we will need the acoustic devices to monitor leakage. We need video camera to for asset management, also for security, like watching whether something or someone will disturb our assets, something like that. Smart water meters, pressuring monitoring, and etc. etc. So this is depends on what is the purpose of your water management system. And the second is control, basically control system, or in modern or industrial level, maybe they use supervisory control and data acquisition system of SCADA to process information and remotely operate and optimize system and process. So here is where the management of parameters that need to be managed, well managed, is being taken care of. Okay, so if there we can operate, we can design this to work autonomously. I mean, to work without the appearance or the intervention of human operators, or we put it with operators to work. It depends on the requirement or the importance. Next, since we tend now the trend is to manage everything, how to say it, across border of countries, across border of geographical borders. So geographic information systems nowadays is also included in a smart water management system. The purpose is to store, manage, and manipulate and analyze spatial information. So this is will be useful when our asset is across the large area or distributed in separated areas. And of course, because this is a smart water management system, is something that we cannot fully operate it manually. So we need help of ICT, So ICT needs software, and then we have to provide software to store, to use, the report data from modeling infrastructure, environmental system to improve design, decision-making, and risk management. So usually all system is integrated from the first digital output instrumentation, supervisory controller, geographic information system, and software. So usually they all being integrated in one system or one cluster of systems. Okay. Of course, this is the ideally for when we are going to manage water in a very complex infrastructures, many purposes of water use utilization, etc. Okay, so I hope after we talk about the previous parts, we can have idea what is the answers of these questions. First, what is the purpose of smart water management? So maybe later you can try to answer or we can discuss. And the second, what are the keywords of smart water management? And the third, how does smart water management work? Okay, before I continue to the next section, maybe anyone want to give comment or question or try to answer this question. I give you 1.5 minutes to give response either directly or by chat. Okay, anyone? Or does anyone not yet have idea what is the answer of these questions?
I'm sorry, I think Henry raised his hand. Mr. Satianto.
Actually, I would like to ask a question, sir.
Okay.
All right. Is it? Am I allowed?
Oh.
Hello.
Yes.
Yeah.
Please.
Right. So my question is that how accurate and transparent is the smart water compared to conventional one? And question number 2 is that connection-wise, how do you see this technology will work in rural area, as some of our region in Indonesia doesn't have a proper internet connection. So because I think this water management really rely on internet connections. So how do you see that, sir? Thank you.
Okay, I'll try to answer the second question first. Actually, Indonesia is already being started to being implemented, especially in water resources management by Ministry of Public Works or the institution under it, because there were some, I think, the webinars that shows how they manage the information of the one reservoir, I think not reservoirs, or one watershed. I don't remember. However, they already implemented. Of course, internet connection is the one of biggest obstacles in our development of smart water management. However, if the institution of the infrastructure is, how to say, big enough, so they can provide their own intranet, I think, not internet. So there's no such big problem for them, I think. Of course, if we are talking about the how, I think the first question is more like how can we implement this in rural area in Indonesia? Am I right?
Yes, so that's the.
Hello, Ardi.
Yes, sir.
Can you repeat your first question?
So connection-wise, question number 2 is that connection-wise, how do you see this technology will work in rural area Indonesia regarding that? Not, I think some of the regions don't have access to like a proper internet access. So how do you see it works over there? And question number 1 is that how transparent or maybe how accurate is this smart water meter compared to the conventional one? As some also like institution did this kind of like a dirty job, like a cheating. So I would like to know how transparent it is. Thank you.
Oh, okay. Maybe yeah, it's a good question, but difficult to answer. Actually, I'm doing after this. I will show you some examples we've been done within several years. I think that we can apply it, well, actually limitedly applied in rural area, but it does work. It does work actually. However, still the internet connection is one obstacle. Whenever the internet connections does not present, of course, we cannot afford, yeah, with the use of internet connection, but we can enrich, I think, the connection with other technologies such as a long range. I don't remember the terminologies. They the term is LoRa, long range radio. Don't remember, but it is possible to connect two devices up to, I think, maybe 10 kilometers, something like that, line side. So we can limit our connection to where the connection of internet is available, and then the other we can use other model of connection, I think. So yeah, I think that's what kind I can answer up to until now. Maybe later we can discuss. Okay.
Thank you, sir.
Is it answer your question somehow? Actually, I know I didn't answer some of your question, but I think we can discuss after the next section of this lecture. Is it
All right.
okay for you?
It's okay, sir. More than okay.
Okay. Okay. Let's move to the more specific purpose of water management. Is actually I will only show you some of example what we are doing related to water management system in agriculture. So the first is this is what we are still doing now. This is the project or cooperation with Ministry of Public Works, and the aim is to update how to estimate the water requirement for agriculture. So we have to put some measurements. Yeah, actually not. Yeah, measurements or observation is more likely observation. Of course, within the observation, we have to put some devices to monitor the measures. And because we were asked to observe in different climatically different and geographically different location, including there's types of soils, types of climate, something like that. So up to now, we installed the observation station at 4 regency. First in irrigation area in Cianjur Regency, and the second is Karawang Regency, and third is Wajo Regency and Goa Regency. The first two are in Jawa Barat, West Java, and the second the last two are in South Sulawesi. So we put this kind of devices. This is a telemetrical automatic weather station. Yeah, automatic weather station with telemetry data loggers. So we also connect this kind of measuring, how to say this. This is cutthroat flow. Maybe anyone of you familiar with hydraulic term of discharge management. This is cutthroat flume. So we put sensors to measure the water level, and using the flume equations, we can calculate the discharge, something like that. And it's connected to our telemetry data logger, and it sends data directly to the servers. So the purposes of this measurement is we have to quantify what is the land preparation water requirement, what is the consumptive water use for each location. The land preparation water requirement is when you prepare the land before transplanting rice, actually. And consumptive water use is after you transplant the rice, and until we can harvest what is the amount of water. This is basically the evapotranspiration, actual evapotranspiration. And then we have to quantify the loss through percolation. I think it should be percolation in seepage here. And then during the land preparation, there is one water requirement called water layer replacement. This is a little bit difficult to explain, but when after you prepare the land, then you have to you drain the land, then you give fertilizers, and then you have to add water again to give the land enough standing water. And the fifth is to quantify the effective rainfall. This is the amount of rainfall that actually can be used by crops, something like that. So we want to update how to calculate or estimate this, and in order to do so, we need data, and the data we are measured by using the telemetry. So as I mentioned before, that one part of smart water management system is the real-time information monitoring, something like that. And then we have to analyze. Of course, in this case, the analysis will be done not by system, but we make like a macro-enabled spreadsheet, something like that, so we can calculate and estimate the quantity of these parameters. And these are our settings. If this is the quarter block, I think secondary water from the dam go through primary canals, and then divided into secondary canals, and then again divided into tertiary canals, and then divided into quarter box before they distributed into a quarter block fields, something like that. It's difficult for me to explain in English because I think it's specific in Indonesia. Anyway, we have one field, one block measurement. What is the in charge and what is the discharge, and also we have two plots of interest that we observe with more detailed observation. What is the irrigation, what's drainage, what is the weather, what is the percolation, what is the evapotranspiration through lysimeter, something like that. And everything is recorded automatically, and some are using telemetrical data loggers. So these are example of what we are using the system. So these guys here connected to servers and through internet, and we collect the data from the clouds. There's actually some problems with this connection, but the provider offered another types of connection, like when internet connection is not reliable, or we have to went deeply into wood, maybe something like that, we have to choose other connection system, and yeah, like that. Okay, this is the dashboard. Yeah, the dashboard at the dashboard for our devices, and they provide the actual condition, actual data measured at the time, and also the graph, the variation of the parameters, the variables measured at the site. And this is actually I would like to present some chart, yeah, some graphic resulted from our analysis. However, I have some problems in calculating or analyzing the data. So maybe I can show you just what kind of data we can acquire. We can acquire from the field. So sorry, this is in Indonesian, but however, most of you are Indonesian, so you can read. Yeah, so we acquired air temperature, humidity, solar radiation, rainfall, pressure, wind, and what is the percolation. I think this actually not directly percolation, but the level of reservoir to supply water to percolation pipe, something like that. So we have to calculate. This should be calculated further. And this is the water level or genangan in Indonesian, in bahasa Indonesia. Is the thickness of water layer above the soil surface, and this is the it should be the actual evapotranspiration, but also we have to analyze this before we can present the values. This is what we are doing, but this is only how to say, only monitoring. So there's no action related to the data we are collecting. This is more like we use this to revise or to propose revision how we estimate water requirement for the planning of irrigation area. Yeah, something like that. But this is the I think this is the most, how to say, the critical or the vital system that should be existed or used in a smart water management system. Now we go. Sorry, this is me in one sawit plantation. Anyway, look at the title, automatic irrigation and drainage. Well, actually, this figure also the automatic irrigation, subsurface irrigation in Lombok area by one of our graduates in, I think, 2016 or 2018. I don't remember. Okay. Now, when we are talking about the automatic system, so we should have idea what is automatic, what is manual. So in my opinion, when we are talking about a good, well-designed system, whether it's automatic or manual, I think the difference is only like in this figure. The right side is manual, where you are controlling the devices, controlling the system. And when it's automatic system, then you are replaced by a controller that can work independently. So in this case, when we are going to apply automatic system, smart system, we should design the infrastructure or the system. It should be able to be operate without the smart system. I mean, the infrastructure should be well designed. Okay, so because when we want to apply for example, we want to apply sensors. When in our infrastructure, there's no place to measure, so we cannot use sensors. But when we have the facility to measure, to place the sensors, and we don't have sensor, or the sensors are failed to work, and we can do it manually. We can measure manually. So I hope this can be understood. Okay. The automation system for irrigation is a system that can work autonomously, of course, work according to the given settings. I mean, in this case, we have to decide what is the condition of soil, what is the moisture, soil water condition that should be kept, should be given to provide to the plant, and therefore it is impossible to use when our design for example, the irrigation network was not designed well. Okay, so we want the automation system to work according to the given settings. And there's two examples of automation system. First is by using timer. It's very easy and very cheap. You can buy the timer, I think, in marketplace. If you are interested to plant something in your house, you can use the more economic technology products. And the second example is by setting the wetness of the soil. Like in this figures, actually in the one greenhouse in IPB campus, we put sensors in one of the spot, and this is the controller, and it will control how water go, when to irrigate water to the network, the pipe network. Okay, when we are talking about automation system, we can avoid this to talk about this, the closed loop control system. So basically, this is a process, closed loop process to. Let's look this process. The process that should be controlled, or the process that will be interfered. And in this case, for irrigation, for example, the process is actually water balance. The plants take water from the soils, and also there's some evaporation, some losses, and then the condition of water is sensed by sensors as measuring element. The sensor reads the soil moisture. For example, in my case, the case I showed you before, the sensor reads the soil moisture and passes it into the controller. This is the controller. The controller, we can use many things as controller. In short way, the controller should be able to compare the condition of the information from the sensors to the setting that we are going to keep. For example, at field capacity or at water level at certain level, something like that. And then in this case, soil moisture compared to that desired by the controller. I think the desired mean we put the setting into the controller, the set point into the controller, and it compares the information from sensors, and then the controller will decide whether to activate the actuators when the requires irrigation is needed, and the controller will give commands to actuators to give the irrigation. So there goes the manipulated variables, and then as the water is given to the the soils, water quantity in the soils increased, and when it reached the certain condition, then the controller will stop the irrigation. So this is how it works. Much more. This is more theoretically. It's basically it's control system. Yeah, maybe those who familiar with electrical or computer science, I think, very know this well. Then we are talking about when it's going to the irrigation or automatic irrigation. This is one example. We use sensors. We use soil moisture sensors. Yeah, it functions to find out how much soil water content, soil wetness, soil moisture. In other cases, maybe it detects the water level, something like that, or water quality, something like that, in the soil quality. And in this case, this kind of sensor can be installed by plugging into the ground or planting media, and it will reach the percentage of volume, wetness volume, and it will provide information whether the required level of wetness had been reached or not. Required level means that, for example, we want to keep it at field capacity, and whether it already reached field capacity or not. Okay, this is example of the controller in the greenhouse. It functions to replace the operator to turn on and off the irrigation equipment, and operates with reference to planting media, soil moisture sensors, and these can be many things. We have many choices of controller, from computers, mini PCs, gadgets, even clouds or local servers. Okay, but we have to program. There is software things come. Okay, this is the actuators. Actuators actually serves for irrigation actualization in this case. So it's actualize the comments from the controller. For example, the controller asks commands to give irrigation, then the actuators will actualize the comments. It can be like this. This is solenoid valves. This is motorized valve. It can also be electrical pumps, electric gauge, something like that. In this case, depends on the needed. So we go to another example. It is automatic sprinkler irrigation. It's actually in lab, I think several years ago, by our student. So the sprinkler, very small, and the setting is not so well described here, but this is the reservoir with, I think, 5-meter height. So it provides 5 meters equivalent of a head, I think, hydraulic head. The pressure, so it's pressurized as I say, the emitters, and then actually in this part we have solenoid valves and controller. So this is yeah, I can say the circuits, yeah, the control circuits. We'll skip this, and this, after we operate the automatic irrigation, we put sorry, this is in Indonesian, but this is actually the upper limit of wetness, and this is the lower limit of wetness. So we want the wetness of soils within this range, and whenever it touch the lower limits, irrigation turn on, and water will added to the soils, and soil wetness increase. And after it touched the upper limit, then irrigation stop, and then the soil wetness gradually decrease like that. So it's going like this automatically, and it can be very short, it can be longer, depends on the condition of the weather and the time. I think in the morning, in the noon, afternoon, or at night, maybe it's different. Okay, the second example is for paddy field actually. The previous example is to control soil moisture. In this case, we control the water level. It's similar, well, however, we upgrade the system here. We put solar panel as what is it? What called the energy? Yeah, something like that. The energy. So we put sensors and we put controllers here. However, in these two examples, we're not yet connected to internet. Okay, so this is more the water management system. Maybe it's very small or micro scales. So it stop the information stop at the microcontroller who control the irrigation, but we can download the data using computers. So I think we can proceed. And I think at the first lecture, someone asked about how to apply the SRI in organic land, organic peatland. I'm not sure whether it can be used. It can be implemented in peatland because the characteristic of the soils, I think, is different from what is usually used in I can say in Java and in peatland, because peatland, aside from the peat itself, also it usually faces the fluctuation of water level. Sometimes it got too high and flooded, and the land is being flooded, and sometimes it decrease and no water can be used by crops. We're talking about crops, not annual trees. Yeah. So crops has a very short root, I think. So when the water goes down 1 meter or more, then I think it's difficult for the crops to get water. And in this case, a long time ago, we have developed some water control for wetland. So the aim is to keep the water table at the certain level, in the desired level. So in this case, we put like this is pump, this is a computer, and this is the electronical the controller system. We use computer at that time, and we use 2 water level sensors, and we use 2 pumps to drainage and to irrigate. And in this research, we used artificial intelligence, actually, the fuzzy logic controller at that time. But however, how does it work? Maybe it's too small, but the fluctuation here is the fluctuated water at the canals or river. I don't remember. I think Ananda know this place. This is in Pemulutan, South Sulawesi, Palembang. I think you know the place. So this is the water fluctuation, and we want to put the water table at this level. However, it's very difficult. So, well, the system works, but can only, keep the water such like in this figure, the lighter blue. So whenever it will be success to when you apply smart water management system or not, it depends on many things. At first, maybe when it goes through to the large area, so I think smart water management system, I mean the automatic water management system maybe can only works on micro scale, but in the macro scale we have to uh, uh, design the water management infrastructure first with a good design. Okay, so after we discuss talk about the more in automatic irrigation drainage system, then I hope any of you can have idea what are the components of automatic irrigation and drainage, how does the automatic irrigation drainage work, and in order to ensure the smart water management system works, what should we be well prepared? Okay, does any of you want to give comments or questions? Maybe we have now is, I think we still have time because the next section is very short. Anyone?
Yeah, Dr. Satyanto, can I have a question?
Please.
For the AWS telemetry, how big the
Yes.
areas can represented by the telemetry? Is it like one equipment can measure for each quaternary blocks or tertiary fields or secondary fields? I mean, should farmers buy and put the telemetry for their each fields? Also for the automatic sprinkler irrigation, is it economically feasible for farmers if they have only like, let's say 1 hectares of their farms? Thank you.
Okay, very good question, and again, very difficult to answer. First, maybe the last part, whether it will be beneficial or not. It is the biggest question and that is still challenging. You know that the price of this kind of automation system, telemetry system, nowadays is decreasing, but still it requires investment. So maybe at this time, it's still difficult to put. So when you invest smart water management system, telemetry system, of automatic system to your farmland, then it's still difficult to exactly answer whether you will have increase in your benefit economically. So we have to take that that's the reality now. However, if we can, because in my opinion, there's it's not always economical benefit that we have to directly financial benefit that we can I say should be aware, should be considered, but also sometimes the uses of technology can help to get the how to say the industry to work. I mean, in agriculture, I think there is not so easy to find workers or from younger age, I think. But when we introducing smart system, when we use application, something like that, some of the young people would like to, I will go to in the farming industry with modern technology, something like that, including the automation system. but answering in 1 hectares for sprinkler, I think it's the answers maybe not will not be the same for each case, but we have to plan, and we have to calculate first the investment and the benefit. Yeah. And I think your first question is how what sensors is what is the amount of the number of sensors can be representative to one field. I think something like that, right? So
Yeah.
one sensors can only detect at its location. So when you put it in the middle of the land, then the data actually only there. So when we want to apply sensors, maybe there are two approaches. At first, we make boundaries. So we make sure that when a sensor put boundaries and uniformity, uniformity by design. For example, in pipe irrigation system, there's uniformity coefficient. When we can get the uniformity, then we can put just one sensor for one network that we can assume it as uniform. So it also, the answer will not be the same for every case. We have to design, and we have to study it first. But when we are talking about, for example, paddy field, we want to know what is the water level at the paddy field. Then it's easy, because paddy field usually have the pematang itu apa namanya?
The border.
Yeah, the border. And water cannot go outside. Then, when water is in one basin, so I think the water level will be the same. So we can use, if your land is, for example, maybe 3,000 meters square, you can put it one sensor is enough. So very different on the cases, I think. What's your other question? I think I forgot.
No, it's enough. But I'm just also curious about, since you show the photo in the oil palm plantations, does the palm oil plantations requires irrigation?
Indonesia, as far as I know, palm oil plantation for the productive plant, I think I haven't seen any irrigation. But in the small tree, what's the bibit? What is it in
nursery?
In nursery,
yes.
In nursery, they always use irrigation system by sprinkler, I think, mostly. But in other country, maybe they use some kind of micro sprinkler or something like that for production tree. I don't have many experience in palm oil, actually. That was the pictures was my first time, actually, to try to put a sprinkler in a palm oil plantation.
Okay, thank you, Dr. Satyanto.
Okay, it's enough. Okay, we continue. I think already the next is not so long talk. I just want to introduce. Oh, there is Zaki. Zaki, do you want to ask something or want to comment?
Yeah, I wanna ask something. As you stated previously on the slide, there's this technology of sprinkler automation technology. But how about the drip irrigation, which I think is also kind of popular as one of the solution of modern day agriculture, and I think it is kind of similar in terms of amount of water used for the plant. Yeah. Have you ever
Okay,
have?
Zaki.
Yeah.
Okay, yeah. Please
Is my
continue.
voice clear?
Yes, yes.
Yeah. Have you ever have
It-
an experience regarding to the automation of drip irrigation? Thank you in advance.
Okay, Zaki, are you in IPB?
Yeah, I'm in IB right now.
Yes. I mean, you are a student of IPB, right?
Yeah.
Then you can try to browse the repository description of your seniors. I think lifting 45. There was uh, uh, final assignment description thesis about the automatic drip irrigation that was done by one of your senior. But anyway, the one of the most already available in the market. Either you are using the sensor, or you are using the timer. Okay, so it's not so new, and many plantation, many company or many person had already been using it. Last month, I went to Nganjuk with Dr. Prastowo. They also applied the automatic drip irrigation system for their greenhouse. So if you are interested in learning that, I think there are many examples, many places to. Okay, I think we continue first, and later if we still have time, you can ask more. Okay. Okay, then this is my current research, and this time, the management system in this case is much more. I can say much more difficult, maybe, because we supply water through the underground, a subsurface irrigation system, and we use this kind of reservoir to still the head of the water. So when we put it for example, 5 centimeters from bottom, and the water inside the water that go through the subsurface irrigation system, the perforated system, will have equivalent head, so it can rise up to 50 centimeters also. Then we put the sensors to detect the water level at the reservoir. We connect to the data logger, and we put the control system inside the data logger. But the data logger also send data through the internet to our cloud servers, and we can access the data from our gadget or laptop. Okay. Then in this case, maybe we don't have time to show this time, but I can change the settings. I can download the data from my computer right now, because it's still operated in IPB campus. This is still a small scale or laboratory scale model. However, it's possible to implement at field scale. So this is a dashboard similar to the one I showed you about the telemetry and water requirement observation, field water, agricultural water requirement previously, but this is specialized for control system. In this Kendali irrigation control actually. So this is the chart. This shows this is drainage, this is irrigation. So when the upper chart shows the green bar like this, it means that drainage is occurred. Yes, drainage occurs, and the lower is irrigation. So I can change the set points, the water level that should be kept in the system, and the system will control automatically. Okay, then this is we try to change the water level set point, and the system can follows. Yeah, you can the purple one is the actual water level, and something like this. Anyway, the system works, and also we try to analyze what is the soil moisture condition, because this is basically we control the water table. The level of saturated soils in the field or in the box, and we have to make sure that at the root level the water is sufficient. Okay. This is what we are doing now. Still doing. This is the last year, I think. If anyone from any of you want to see, you can contact me. We can see it together. It is at Wisma Wageningen, if you know, not in Netherlands, but in Bogor campus. Okay, so we go to water footprint. Yeah, this is only a short introduction, I think. Why water footprint? Because at our previous research, we try to connect our development of technology to what is the environmentally sound parameter. So how eco is our technology is like that. So one of the parameter is the water footprint. Water footprint is the measure of humanity's appropriation of fresh water in volumes of water consumed and or polluted. So basically, what is the amount of water you use? What is to make products, any products, and what is the amount of water you use to clean what you have messing up, the pollution, the consume and pollution. Okay, this is from the Water Footprint Network website. The water footprint allows us to answer a broad range of questions. For example, where is the water dependence in my company operation or supply chains? How well are the regulation of protecting our water resources? How secure our food and energy supplies? Can I do something to reduce my own water footprint and help us manage water for both people and nature? And it includes direct and indirect use of water. For example, in agricultural sectors, maybe the direct use is to irrigation, for example. But indirect use may be what amount of water involved in the production of, for example, 1 kilogram of rice, something like that. So there are 3 water footprints. First, the green water footprints is water from precipitation. And second, blue water footprints is water that we took from surface water resources, groundwater resources, something like that. So irrigation, whenever it took from river, is blue water footprint. But when we have the filtered rain-fed field, so it's green water footprint, something like that. And don't forget, in agriculture, we put fertilizers, we put chemicals, and it somewhat polluted the water. So gray water footprint is amount of fresh water that should be used to assimilate pollutants that we consequently produce after our activity in producing one kind of goods. So we try to calculate the water footprint for our automatic technology. Well, actually, it's for student final assignment only. So, for example, in this case, this is the automation, the automatic subsurface irrigation system. We try plant rice at the box I showed you previously, and here we have to, at first we have to estimate, or we have to calculate what is amount of water we used to produce the rice and where it came from. Okay, so we have rainfall, we have irrigation, we have drainage, and then we have to the evapotranspiration for a plant can be calculated, but we have to separate it into the green and the blue because the water source is from rain and also from irrigation. And then we can calculate water footprint in green water footprint, blue water. Then we have to calculate what is amount of minerals we use in fertilizer and in chemicals. Commonly, we calculate based on nitrogen and phosphorus. Actually, there's also potassium, but in this case, it's not detected. So we did not calculate. And then we can calculate the green water footprint. The second example is also automatic irrigation with a solar panel irrigation. This is at the back of FEB campus. We also here, we have to estimate the evapotranspiration, we calculate the rainfall, we calculate the seepage. In this case, at that time, there's no irrigation water from water surface, so all is from rain only. And then we calculate what is the green water footprint. Sorry, this is the green water footprint, and there's no blue water footprint in this case. And also we calculate the amount of nitrogen and phosphorus that used in the fertilizers, and we can quantify the gray water footprint, something like that. So in this case, we can add some insight that how environmentally friendly our technology is when it's applied to such agriculture system. Okay, so before I leave this section, there's another terminology that similar to water footprint. It's the water productivity. So these are the definition I took from the websites. The right is water productivity, and the website is the water footprint. The most, I think the major differences is the unit. I think the unit is reciprocally. So water footprint is having unit unit volume of water per unit mass of product, while water productivity is the unit mass of product by unit volume of water. And also water productivity is mostly in biomass production. So please visit the website and look for yourself the detail of these two terminologies. Okay, I think we go to the remarks. These are remarks I would like you to understand, or I want to hear. First, the smart water management system is a support system in managing water to optimize water utilization for various purposes. And the water management itself should be well designed and evaluated, how it impacts the environment. The existence of professionals or experts who master the field of water management cannot be replaced. So whether you have any automatic system, smart system, you cannot replace someone who master in the field, because sometimes things happens and it should be being handled manually. So in absence of smart water management system, the water management system itself should be able to be run conventionally. So we have to carefully design before we apply this water management system. So I think that is what I can give for today's. I hope we have everyone have the I can understand what I am talking from this morning. Thank you very much. I return it to the moderator. Thank you.
Okay, thank you so much, Dr. Satyanto, for your course and presentation. And I see that Andre Dani raised his hand. Maybe Andre Dani, can you open your microphone and say what you want to say?
Yeah. Thank you, Dr. Satyanto, for your interesting presentations. For the last sessions, can we measure or determine the water footprint, especially using remote sensings? Because you just explained using the sensor and yeah, tools in the fields. Thank you.
Okay. Okay, very good questions. Actually, in 2000, I don't remember, 2006 or 2010, I think. That was the first time I know the terminology of water footprint. And I was introduced by a professor from Twente, the University of Twente, I think it's in Netherlands, in Enschede.
Yeah, Aryan
And,
Hoekstra, right?
and not Hoekstra, but other professor. The name is, we call it Bernie van Groosen. It's actually from mathematics department, but he introduced us the water footprint, and he introduced how to, if we have limited data, how to we can interpolate the the data required for water footprint or the water footprint itself. So he also we were also introduced to uh, uh, I think people from ICT, international ITC, I mean international training. I don't remember the C one. Anyway, the person is from special. The specialist is GIS. So we introduced the remote sensing, and basically remote sensing can be used to calculate what evapotranspiration, right? So we can use the, for example, Bastianson's surface energy balance model. It use spatial remote sensing data from I think temperatures and other data. So basically, yes, we can use to estimate the evapotranspiration. However, when we want to separate either it is the green evapotranspiration or blue evapotranspiration, there's another case. That is another. We have to do further analysis, I think, because it depends on how much rain you have, how much irrigation you give. Basically, yes, we can calculate using remote sensing. Is enough?
Okay. Yeah. Thank you.
Okay, thank you so much for Andre for your great question. Maybe for other participants who want to say about question or maybe something idea to Dr. Satyanto, just raise your hand and open your mic. Okay, maybe I will wait for 10 second. Okay, if there are nobody want to ask or say something, maybe we can move to the next agenda. Okay, thank you so much for your dynamic session, Dr. Satento. And please stay here just a moment because there will be a process of giving certificate for summer course from summer course committee, and you can see it on the screen. Thank you so much, Doctor. This certificate will be sent on your to your email letter, and now we would like to take a documentation with you and your certificate. Please hold on. One, two, three. Okay. Thank you so much. Okay, once again, thank you so much for your dynamic session, Dr. Satyanto. Honorable participants, before we move to the next course, now we will have a break until 10 a.m. GMT plus 7, and please attend this course on time. And don't forget, there will be a quiz for today that will be held that will be start at 3 p.m. and will be closed at 7 p.m. at OCW. Thank you.
She spent all her time in the depth of a forest with her 8 little friends. There was a hidden secret place, so magical and dangerous at the same time. This is the story where the culture had start. And now, let me take you on a journey. So welcome to Wonderland, Indonesia, the sacred Nusantara.
Hidung gigi ronggang, sapi ketawa dolong di